Continue with what should be a trip down memory lane for most of you from previous classes. Let's look at a little bit at spectroscopic notation, which we need to be familiar with. Again, primarily doing some in talks and talking about these details. The principal quantum number n, which can be 1, 2, 3, etc., is could is also indicated by some spectroscopic notation. The early day X-ray scientists, chemists, and physicists had introduced an earlier scheme and talked about electron shells as part of really the Bohr model of the atom. And the quantum number n, for n is 1, they referred to it as the K shell. The quantum number n equal to 2 is the L shell. The quantum number n equal to 3 is the M shell, and so on. And basically they started at K and they went in alphabetical order. Usually in X-ray spectroscopy they will deal primarily with K and L shells, and sometimes the M shell, so n equal to 3 levels. They had introduced those based on experiment, essentially, in their study of X-rays in the early years of the 1900s. You might ask, well, why did they start with K? And so, well, they'd been burned a few times before, and with deals like this, and so they thought, well, there might be maybe shells that were even closer to the atom nucleus than these, and so just to be on the safe side, they left A through the K value here, through J, I suppose. They left those available in case they ever discovered some lower energy states that are closer to the nucleus. You know? So that's the reason for starting at K. In any event, you'll hear people talk about K shell and L shell electrons, particularly if they're in X-ray spectroscopy. People had been studying line spectra since the time of Fraunhofer in the late 1800s, and so they had also introduced some notation associated with line spectra that were observed through their various prism and diffraction grating spectrometers. And they had introduced a notation that is related to the orbital quantum number L. And remember, L takes on integer values. It depends on n, but ultimately it starts, the lowest is 0 and goes on up from there. And the early line spectra scientists had put together a convention of labeling spectral lines based on a slightly different notation, namely this S, P, D, F, etc. They really just did the first 4, and the symbology. These are all lowercase letters traditionally, and the S came from being a very sharp line, a spectral line. P was primary, so the P's were usually the brightest ones. D were rather diffuse and kind of washed out, and F, when they looked at those spectral lines, it resulted from L equal to 3. Those were very, very narrow and fine, thin lines for the most part. So they had introduced that notation, and first just started calling them sharp, primary, diffuse, fine, but then abbreviated that to SP, D, and F. After that, they didn't name anything, but they match up, as I'm sure you know. 0 is an S state. L equal to 1 is a P state. L equal to 2 is a D state. L equal to 3 is an F state, and so on. After F, they just went in alphabetical order, except there is no J state if you go and look through these higher values, which is rare. And the reason there's no J state is that in some languages their I and J are essentially the same letter, and so they chose I guess in the first scientifically, politically correct decision, they decided to uh, to just omit J and have I guess, to make the people from countries that didn't have both an I and a J feel more comfortable, I suppose. uh, but the usual spectroscopic notation uh, for n equal to 1, well, L can only go from 0 up to n minus 1, so n minus 1 is 0, so L goes all the way from 0 all the way up to 0. So there's only one value for L. And uh, the, the principal quantum number is the 1 here, and then the angular momentum quantum number L is the S state, so this would be a 1s electron if it was there. For n equal to 2, L goes from 0 up to n minus 1, so 2 minus 1 is 1, so the two values are L equals 0 and L equal to 1. And those in the spectroscopic notation is 2s and 2p, so if you're in this state, it would be called a 2p electron. If you're in this one, it's a 2s, and so on up the chain. Again, this should be old hat to everybody here. I'm sure it is, and so I won't belabor it. You almost well, I've never really had to deal with anything beyond 4, but there may be occasions that you have to go up to 5 and higher. But in any event, it's all based on the principal quantum numbers being from 1, 2, 3, and so on, and L going from 0 in integer steps all the way up to whatever the n value was minus 1.